Hello, good morning dear students. Welcome to Interactive Virtual Class Nagaland once again. So students, we will continue with the same chapter, that is combustion and flame. So let us see, alright. Now if you remember, we have studied different sources of fuels in lower classes. Yes students. So let us see some of the sources of fuels. So we have cooking gas, right, known as LPG or liquefied petroleum gas. Then we have kerosene. Then we have petrol, and we have ethanol. So these are some of the sources of fuels. Now we use these fuels for different purposes. Yes students, we use LPG for cooking, we use petrol to run cars or vehicles. Yes, and these fuels, okay, are highly combustible substances. Now what are highly combustible substances? Combustible substances are those substances which catch fire, right, or which can burn. But what about highly combustible substances? Let us see, right? So you can note down this. So substances which catch fire in a very short time are called highly combustible substances. So some of the examples that we have just discussed includes LPG, kerosene, petrol, ethanol. Now when you bring a lighted matchstick near the gas stove and turn on the gas, it catches fire in a very short time. It catches fire very easily, right? So LPG is a highly combustible substance. So substance which catches fire in a very short time is called highly combustible substance. Let us see some more examples of sources of fuels. We have cloth, then we have plastic, then we have wood, and we have rubber. So these are also some examples of sources of fuels. Alright. Let us answer the first question for today. Please get your rough devices ready. The question is, which one of the following is a combustible substance? So again, it is a revision question. We have already discussed about combustible substance. So we have four options. I'm giving you 15 seconds to respond to this question. Your time starts now. Which one of the following is a combustible substance? Iron nail, glass, stone piece, wood. Yes, students. Alright, students, your time is up, and yes, very good. The correct answer for this question is option D, that is wood. Iron nail, glass, and stone piece, these are non-combustible substance. So option D, wood, is the correct answer. Alright students, so we have seen the sources of fuels. We have seen some examples of fuels. So what is fuel? Fuel is a substance that produces heat and light energy on burning. Okay, so what is fuel? Fuel is a substance that produces heat and light energy on burning. Now, let us see some of the examples of fuel, okay, and their physical state. So the first example we have is candle. So the physical state of candle is solid. The next fuel we have is firewood. Firewood is also in solid state. Petrol is in liquid state. Liquefied petroleum gas, okay, is in gas state. Kerosene is in liquid state. Diesel is in liquid state. Coal is in solid state. And CNG or compressed natural gas is in gaseous state. So we have here some examples of fuels and their physical state. Yes, students. So we see that fuels can be solid, it can be liquid, or it can be gas. Right? So fuels are classified into three types based on their physical state. Okay, so we have solid fuel, liquid fuel, and gas fuel. We have also seen some examples of solid fuel like firewood. We have seen example of liquid fuel like ethanol, petrol, and we have also seen examples of gas fuel like LPG, CNG. Yes, students. Now let us see here. Here we see a lady, okay, making fire using firewood. Now we see that she poured small amount of kerosene and bring lighted matchstick near it. Now that is how she started this fire using firewood. So in this case we see that the lady is using firewood for cooking. Yes. And here we see again, okay, another lady. She's cooking, but she's using gas stove. And gas stove we use LPG, right? Liquefied petroleum gas. So here LPG is used for cooking. Then here we see on the side of the road, a man is using charcoal, okay, to roast this maize or corn. Yes, so here charcoal is used for cooking. Here we see that different type of fuels are used for cooking. Now here we see, okay, an auto rickshaw. Now how does this auto rickshaw run? Yes, students, they use fuel, right? So what type of fuel do they use? They use CNG. Okay, so auto rickshaw, they use compressed natural gas to run. What about other vehicles? What type of fuels do they use? Yes, students, cars or vehicles, they use liquid fuel. But what type of liquid fuel? They use liquid fuel like petrol or diesel, okay, to run the vehicles. So here we see that vehicles like auto rickshaw, different cars, we see bike, yes, ambulance, these different vehicles, they also use different fuel to run. Auto rickshaw use CNG, that is compressed natural gas, and car use liquid fuel like petrol or diesel. Alright students, so we have another question. Please get your rough devices ready. The question is, which among the following is a liquid fuel? We have four options: coal, petrol, wood, charcoal. I'm giving you 15 seconds to respond to this question. Your time starts now. Yes, students, which among the following is a liquid fuel? Coal, petrol, wood, charcoal. Alright students, your time is up, and yes, very good. The correct answer for this question is option B, that is petrol. Among these, coal is solid fuel, wood is also a solid fuel, charcoal is also solid. Here petrol is liquid, so option B is the correct answer. Now characteristics of good fuel. Okay, let us see some of the characteristics of good fuel, or what are the characteristics that a fuel must have in order to consider it as a good fuel. So the first point is, a good fuel is one which is readily available. Point 2 is, it is cheap. Point 3 is, it burns easily in air at a moderate rate, and it produces a large amount of heat, and it does not leave behind any undesirable substances. So these are the characteristics of a good fuel. However, again remember, there is probably no fuel that could be considered as an ideal fuel, because there is no fuel which has all these characteristics. One simple example is wood, right? Wood is readily available. It is easily available to us. Yes, but it leaves behind undesirable substances like ashes, smoke. Yes, so just like that, okay, other fuels, they may have some of these characteristics, but there is no fuel which has all these characteristics of good fuel, and that is why there is probably no fuel that could be considered as an ideal fuel. Alright students, we have another question. Please get your rough devices ready. The question is, the characteristics of good fuel are: option A is, it should have proper ignition temperature. Option B is, it should not produce poisonous products. Option C is, it should not leave any ash behind. Option D is all of this. We have four options. I'm giving you 30 seconds to respond to this question. Students, your time starts now. The characteristics of good fuel are, okay, it should have proper ignition temperature. It should not produce poisonous products. It should not leave any ash behind. Option D is all of this. So which of the following option is the correct answer? Yes, students. Alright, students, your time is up. And yes, we see that characteristics of good fuel are, it should have proper ignition temperature. Yes. It should not produce poisonous products. Yes. It should not leave any ash behind. So all these three, A, B, C, are characteristics of good fuel. So in this case, option D, all of these will be the correct answer. Okay. Option D is the correct answer. Now students, we have seen that we can use different fuels for same purpose. For example, here we use firewood for cooking. We use LPG for cooking, that is liquefied petroleum gas, and we use charcoal for cooking. Our question is, do these three fuels produce the same amount of heat? Yes, students. Do firewood, LPG, and charcoal produce same amount of heat? No, right? So to know the different amount of heat produced by each fuels, it is known by its calorific value. So what is calorific value of a fuel? So the amount of heat energy produced on complete combustion of 1 kg of a fuel is called its calorific value. I'm repeating this, students. The amount of heat energy produced on complete combustion of 1 kg of a fuel is called its calorific value. So the amount of heat energy produced on complete combustion of 1 kg of wood will be the calorific value of the wood. Alright? And this calorific value is expressed in a unit called kilojoule per kg. In short, we have kJ per kg. Okay? So the calorific value of fuel is expressed in a unit called kilojoule per kg. Remember this, alright? So let us see here some of the calorific values of some fuels. So calorific values of different fuels. So let us see one by one. The first fuel we have is cow dung cake. So the calorific value of cow dung cake is 6,000 to 8,000 kilojoule per kg, meaning this much amount of heat is produced, okay, is produced when 1 kg of cow dung cake is burned, okay, on complete combustion. Next we have is wood. The calorific value of wood is 17,000 to 22,000 kilojoule per kg. The next we have is charcoal. Okay, we have is charcoal. The calorific value of the calorific value of coal is 25,000 to 33,000 kilojoule per kg. The calorific value of petrol is around 45,000 kilojoule per kg. For kerosene also we see that calorific value is around 45,000 kilojoule per kg. For diesel also it's the same, that is 45,000 kilojoule per kg. The calorific value of methane gas is 50,000 kilojoule per kg. The calorific value of CNG, that is compressed natural gas, is 50,000 kilojoule per kg. For LPG we see it is 55,000 kilojoule per kg. For biogas it is 35,000 to 40,000 per kg, kilojoule per kg. And for hydrogen we see that it is very high. Yes, students, we see that it is around 1,50,000 per kg. So from here we see that the calorific values of different fuels. In this case we see that calorific value of hydrogen is the highest. Yes, so out of these fuels mentioned here, okay, out of the fuels mentioned in this list, the highest amount, okay, of heat will be produced by hydrogen gas because its calorific value is the highest. So the less calorific value it is, the less amount of heat it will produce. Alright. So the higher the amount of calorific value, the better will be the fuel. Alright students, we have another question. Please get your rough devices ready. The question is, the unit of calorific value is expressed in terms of which of the following? I'm giving you 25 seconds to respond to this question. Your time starts now. The unit of calorific value is expressed in terms of kilojoule per kg, joule per kg, kilojoule per gram, joule per gram. So which of this option is the correct answer? Which of the following option is the unit of calorific value? Alright students, your time is up, and yes, excellent. The correct answer for this question is option A, that is kilojoule per kg. Okay, the unit of calorific value is expressed in terms of kilojoule per kg. So option A is the correct answer. Now let us see the difference between wood and LPG. These are two fuel. Yes, so let us see. Wood is a solid fuel. LPG is a liquid fuel. Now this LPG can exist both as liquid and as gas. Okay, so here we see wood is a solid fuel. LPG can be liquid or gas. Okay, it can be liquid or gas. The next point we have is wood, it produces smoke. LPG, it does not produce smoke. The calorific value of wood is less, right? It is 17,000 kilojoule per kg. The calorific value of LPG is more, that is 55,000 kilojoule per kg. Wood requires, okay, or it needs large space for storage. We need large space for storing wood. But LPG can be stored easily in cylinders. Wood undergo incomplete combustion. LPG undergo complete combustion. Wood, it causes pollution. LPG is a clean fuel. So this is the differences between wood and LPG. Now if we compare these two fuel, which of these fuel is more idle? Yes students, we see that LPG is more idle. Yes, why? Because it does not produce smoke. Its calorific value is also higher. It can be easily stored. It undergoes complete combustion, and it is a clean fuel. So we see some of the characteristics of a good fuel, right? So here LPG is more idle than wood as a fuel. All right. Now we have different other fuels like we see here gas burning in a Bunsen burner. We have camphor. Then we have spirit lamp. We see that forest fires. Right? So in all this case we see that we use different fuels. Yes, but we consider this ethanol, LPG, propane gas as clean fuel, and these other fuels like candle wax, camphor, and burning of waste, they have flame with soot and residue. You will see that when you are using LPG or when you are using ethanol or propane gas, it produces clean flame. But if you use camphor, candle, or burning of waste, you will see that it produces flame with soot and residue. Yes students, so why so? Okay, why so? Why do this fuel burns with clean flame, but this fuel does not burn with clean flame? They have flame with residue and soot. So why is it so? Let us see. So here we have LPG, which is liquefied petroleum gas. We have ethanol. Then we have propane gas. Okay, we have propane gas. So these are clean fuel. They produce clean flame. Why so? Let us find out. Okay. On the other hand, fuels like camphor, then we have candle wax, then we have waste. Okay, we have waste. These produce flame. Okay, with soot and residue. They have smoke. They have some other particles. Yes, students. So why so? Let us see. These fuels, they undergo complete combustion. Okay, fuels like LPG, propane gas, ethanol, they undergo complete combustion. So there is no unburned carbon particles remaining. There is no soot, there is no residue because they undergo complete combustion. Whereas, on the other hand, the fuels, okay, or this candle, camphor and waste, they undergo incomplete combustion. So there is unburned carbon particles or other particles. So they undergo complete combustion. So that is why they produce flame with soot and residue. So it is because of complete combustion and incomplete combustion. Alright students, let us answer another question. Please get your rough devices ready. The question is, which one of the following has the highest calorific value? Okay, so among these four fuel, that is kerosene, biogas, LPG, petrol, which of the following has the highest calorific value? I'm giving you 15 seconds to respond to this question. Your time starts now. Which one of the following has the highest calorific value? Kerosene, biogas, LPG, petrol. Yes, students. Alright, students, your time is up, and yes, very good. The correct answer for this question is option C, that is LPG. Out of these four fuel, that is kerosene, biogas, and petrol, liquefied petroleum gas or LPG has the highest calorific value. Alright, students. Now we have seen about complete combustion and incomplete combustion. Yes, we have discussed about complete combustion and incomplete combustion. Some fuels, they undergo complete combustion, so they produce clean flame. Some fuels, on the other hand, they undergo incomplete combustion, so there is some unburned particles. That is due to incomplete combustion. So we will discuss on ill effects of incomplete combustion. Okay, what are some of the ill effects of incomplete combustion? Let us see. So here we see industries, big industries. Yes. So in industries, they also burn different substances, different materials, right, to produce heat. And here we see a lady, okay, making fire using firewood to cook. Now we see that she is coughing. Now, yes, students. So here we see examples. Those are the two examples where there is incomplete combustion while using fuels. So the first point is air pollution. Okay. The first point that is under ill effects of incomplete combustion is air pollution. Incomplete combustion causes air pollution. Under air pollution, there can be different causes. The first is industrial causes. So fuels used in industries, thermal power plants, releases gases like carbon dioxide, carbon monoxide, sulfur dioxide, nitrogen dioxide, and other gases into the atmosphere, which causes air pollution. Another cause of air pollution is vehicular causes. So we know that vehicles, they also use different fuels to run. Yes, students. So the fuels used by cars or vehicles also causes air pollution due to incomplete combustion. So fuels used in vehicles releases carbon dioxide, carbon monoxide, sulfur dioxide, nitrogen dioxide, and other gases into the atmosphere and causes air pollution. So this is the first point. The first point under ill effects of incomplete combustion, that is, it causes air pollution. Air pollution can be caused by industries, it can be caused by vehicles. The next we have is, let us see here. Now, the different gases, okay, released into the atmosphere by industries, or it can be by through volcanic eruptions as well. So these oxides. Okay, these gases which are released into the atmosphere may mix with rainwater. Okay, may mix with rainwater. So here we see, okay, that when the rain falls, it destroys the vegetation, it kills the plants. Not only the plants, but it will also affect the aquatic life. So one another effects of incomplete combustion is climate. Okay, climate change. The oxides, of sulfur and nitrogen which is released into the atmosphere will dissolve in rainwater and forms acid. Now when this rainwater falls on earth, okay, it is known as acid rain, and this acid rain has some effects, okay, some ill effects on the vegetation, on the marine life, that is aquatic life. Okay. Alright students, before we proceed further, let us answer another question. Please get your rough devices ready. The question is, oxides of sulfur and nitrogen causes acid rain, combustion, ignition, none of this. I'm giving you 15 seconds to respond to this question. Your time starts now. Oxides of sulfur and nitrogen causes which of the following? Acid rain, combustion, ignition, none of this. Alright students, your time is up, and yes, good, the correct answer for this question is option A, that is acid rain. Oxides of sulfur and nitrogen dissolve in rainwater and forms acid. Now this rainwater is known as, when this rainwater falls on earth, it will be known as acid rain. So option A is the correct answer. Now let us see some of the effects of acid rain. So acid rain harms the animals and destroys the vegetation. This acid rain will kill the animals. It will destroy the vegetation. Animals may be both those animals that lives on land, because they also need to drink water. Yes, so if the water bodies, okay, are affected, the animals that lives on land will also be affected. The animals that lives on water, that is the aquatic life, not just animals but plants and animals that lives in water, they will also be affected, they will also be harmed. So acid rain harms the animals and destroys the vegetation. So here we see fishes, we see plants which are harmed or damaged by acid rain. Acid rain also damage buildings and monuments. Yes students, one such example is Taj Mahal. Okay, Taj Mahal. So here we see that acid rain, it also damages historical monuments. Okay, acid rain also damages historical monuments. So acid rain, it harms the animals and the vegetation, and acid rain also damages buildings and monuments. Alright students, we have another question. Please get your rough devices ready. The question is, acid rain causes damage to which of the following? Option A is marine life, option B is plants and vegetation, option C is buildings and monuments, option D is all of this. So I'm giving you 30 seconds to respond to this question. Your time starts now. Acid rain causes damage to option A, marine life, option B, plants and vegetation, option C, buildings and monuments, option D, all of the above. So which of the following option is the correct answer? Yes students. Alright students, your time is up, and yes, very good. The correct answer for this question is option D, that is all of the above. Acid rain causes damage to marine life. Acid rain also causes damage to plants and vegetation. It also causes damage to buildings and monuments. So option D, all of the above, is the correct answer. Alright students, let us see. The next point is on human health. Incomplete combustion also have ill effects on human health. It affects the respiratory organs. Okay, it affects the respiratory organs in human and causes diseases like asthma, bronchitis, etc. So these are some of the disease, okay, or sickness caused by or caused due to incomplete combustion. The next we have is it can cause carbon monoxide blood poisoning. It may cause cancer. Okay, so these are some of the effects of incomplete combustion on human health. Now, when this, okay, due to incomplete combustion, certain gases are released into the atmosphere. Yes, students. So here gases like carbon dioxide, methane, and oxides of nitrogen increases the temperature of Earth, and this phenomenon is known as global warming. Okay, so another effects of incomplete combustion is that it can cause global warming. So here we have two types of flame. We have seen that blue flame means that there is complete combustion. Yellow flame means that there is incomplete combustion. We have seen the ill effects of incomplete combustion. Yes, students. So we are always advised to use blue flame. Okay, we are always advised to use blue flame. Alright, students, we have another question. Please get your rough devices ready. The question is increased concentration of dash in air causes global warming. Nitrogen, carbon dioxide, sulfur, carbon monoxide. I'm giving you 15 seconds to respond to this question. Your time starts now. Increased concentration of dash in air causes global warming. So which of the following gas will cause global warming? Alright, students, your time is up, and yes, very good. The correct answer is option B, that is carbon dioxide. Increased concentration of carbon dioxide in air causes global warming. Alright, students, we have another question. Please get your rough devices ready. The question is, a street vendor you often visit near your school is very friendly with you. He is sick and getting old but sells street food to earn his livelihood. Suddenly you notice his absence since many days. You get worried. What will you do? Okay. So option A is inquire about his absence from the vendors nearby and pray for his well-being. Option B, do not bother about it as he was just a street seller and not your relative. So I'm giving you 30 seconds for this question. Your time starts now. The question is, a street vendor you often visit near your school is very friendly with you. He is sick and getting old but sells street food to earn his livelihood. Suddenly you notice his absence since many days. You get worried. What will you do? Option A is inquire about his absence from the vendors nearby and pray for his well-being. Option B is do not bother about it as he was just a street seller and not your relative. Alright, students, your time is up, and yes, very good. The right thing to do here is to inquire about his absence from the vendors nearby and pray for his well-being. Yes, because we should be kind to everyone. We should look out for everyone. Alright, so option A, inquire about his absence from the vendors nearby and pray for his well-being will be the correct answer. Okay. Alright, students, so in today's class we have discussed about fuel. In the first place, we have discussed some sources of fuels, right? Some examples of fuels like LPG, kerosene, petrol, ethanol. Yes, students. So what is fuel? Yes, students, do you remember what is fuel? So fuel is a substance that produces heat and light energy on burning. Okay, fuel is a substance that produces heat and light energy on burning. Fuel, we have seen that it can be in solid state, it can be in liquid state, or it can be in gaseous state. Yes, so fuel can be solid like firewood, charcoal. Fuel can be liquid like petrol, kerosene, ethanol. And fuel can be gas like compressed natural gas, liquefied petroleum gas. We have seen the different uses of fuel. Yes, we have seen that we use fuel for cooking. We use fuel to run the cars or to run the vehicles. So there are different uses of fuels. We have also seen the characteristics of good fuel. So what are some of the characteristics of good fuel? Some of the points we discuss is that a good fuel is one which is readily available. A good fuel is one which is cheap. Good fuel burns easily in air at a moderate rate. It produces large amount of heat, and it does not leave behind any undesirable substances. So these are the characteristics of good fuel. But we have also seen that there is probably no fuel that could be considered as an ideal fuel. It is because there is no fuel which has all the characteristics of a good fuel. Then we have discussed about calorific value. Not all fuel produce the same amount of heat. So the amount of heat produced on complete combustion of 1 kg of a fuel is known as calorific value. The calorific value is expressed in unit known as kilojoule per kg. In short, it is written as kj per kg. Alright. We have also seen the different calorific values of different fuels. Some fuels they have more calorific value, while some fuels they have less calorific value. We have also seen the difference between wood and LPG, right? We have seen the difference between wood and LPG. We have also seen that some fuels they produce clean flame. It is because they undergo complete combustion, whereas some fuels they produce flame with soot and residue. It is because they undergo incomplete combustion. We have discussed some of the ill effects of incomplete combustion. The first point that we discuss is air pollution. Air pollution is caused by industrial. There is two causes under air pollution, that is industrial causes. The gas, unwanted substance released into the atmosphere by the industries, and it is also caused by vehicles known as the vehicular causes. Then we have seen that another point is climate change. The gases like nitrogen and sulfur, oxides of nitrogen and oxides of sulfur, they dissolve in rainwater and form acid, which causes acid rain. We have seen that acid causes harm to animals and the vegetation. It also damages buildings and monuments. The next is the ill effects of incomplete combustion on human health. It affects the respiratory organs and causes disease like asthma, bronchitis. It also causes carbon monoxide, blood poisoning. It may also cause cancer. Then we have also seen that incomplete combustion may also cause global warming, which is increase in global temperature. So these are some of the things that we have discussed today. I hope you are clear with what we have discussed today. Yes, students. So this leads us to the last question for today. Please get your rough devices ready and give your feedback about today's class. I'm giving you 10 seconds for this question. Your time starts now. How do you feel about today's class? Alright, students, your time is up. Thank you so much for your response and thank you for joining today's class. I will see you again in our next class. Till then, take care everyone and have a nice day.